Hello everyone, my name is Arpita Vittal Gangde. Today's my presentation is about UV visible spectroscopy. So let we start it. So content of a UV visible spectroscopy is a introduction of a UV visible spectroscopy and the principle of a UV visible spectroscopy. Next one, Beer-Lambert's law and that derivation and the deviation, instrumentation of a UV visible spectroscopy and that applications. So first one, introduction of a UV visible spectroscopy. Quantitative analysis of a sample by using UV and a visible light is called a UV spectroscopy. It is also known as a electronic spectroscopy. UV visible spectroscopy is a quantitative technique used to know how much a chemical substance absorbs light. So this is a EM spectrum. Principle of a UV visible spectroscopy is any molecule has either n, pi, sigma or a combination of these electrons. Molecules containing these bonding and a bonding electron absorb the energy in the form of a UV light and undergo a transition from the ground state. By the characteristics absorption peak, the nature of electrons present and hence the molecular structure can be determined. Beer and Lambert's law. The statement states that when monochromatic light passes through solution of a absorbing substance, then the rate of decreases in a intensity of a light with the thickness of a absorbing solution is a proportional to the intensity of a incident light as well as the concentration of the solution. So this is the derivation and the deviation about Beer and Lambert's law, where I is intensity of a light, C is a concentration of a solution, K dash is a molar absorbing coefficient. Next, rearrange this equation and integrate with the limits. Then we get optical density or absorbance, where epsilon naught is equals to K dash divided by 2.303. It is also known as a molar extinction coefficient. There are types of a deviation. Two types of deviation. First is a real deviation and a chemical deviation. Real deviation occurs due to higher concentration of molecules in a solution and also IR of absorbing species. Only dilute solution follows the Beer's law very closely. Second one, chemical deviation. Due to chemical changes such as a pH, association, dissociation, etc., if absorbing species react with a solvent, they may produce more species in a solution with a varying absorptivity value. Second one is instrumentation of a UV visible spectroscopy. UV visible spectrometer consists of the following parts. First one, radiation source. Second one, wavelength selector. Third one, sample cell. Fourth one, detector. So there are types of detectors. First one, barrier layer cell. It is also known as a photo holding cell. Second one, phototube. This is known as a photoemissive tube. Third one, photomultiplier tube. So we see the one by one. Phototube detector, composed of a evacuated glass tube which consists of a photocathode light signal, a collector anode electric signal. Photocathode is coated with a layer of a calcium and potassium which liberates electrons that goes to anode. This flow of electrons towards anode produce a current which is proportional to the intensity of a light radiation. It is more sensitive because of high degree of amplification is used. Second one is a photomultiplier tube. Principle is multiplication of photoelectrons by secondary emission of electrons. It consists of a photocathode and a series of a anode diode chain. Multiplication of a secondary electrons is about 4 to 5 times. It can be detect very low signal. Response time is a 10 power minus 9 seconds. Third one is a barrier layer cell. Operates without use of a battery. Made from base plates of a metals, irons or aluminums that acts as a electrodes on this thin layer of a semiconductor material. When light radiations falls on a cerium layer, electrons are generated. Cerium silk interference. This flow is directly proportional to intensity of a light. So last point is application of a UV visible spectroscopy. To find extent of a conjugation can shift by lambda max to longer wavelength. To distinguish between conjugated and a non-conjugated compound, identification of isomers, identification of unknown compounds, detection of a functional group, identification of a compound in a different solvents. So this is all about UV visible spectroscopy. Thank you so much.